Hello. In this video we're going to look at this question right here. The observation deck at Peggy Cove Lighthouse in Nova Scotia is about 20 meters above sea level. From the observation deck, the angle of depression of a boat on the water is 6 degrees. How far is the boat from the lighthouse to the nearest meter? So I picked this question very deliberately in that I want to illustrate a point about angle of depression. So again, the first thing we want to do here is draw a diagram. So again, if we think about, here's 20 meters above, so this is my observation point. We'll call this O. And then there's some boat out at sea somewhere. Let's call this point B. Now this diagram is not to scale. This is just a sketch to get an idea of what happens and what it looks like. So it says that the angle of depression of a boat on the water is 6 degrees. So this is the part that we want to be sure we understand. So it's saying that the angle of depression from point O to point B is 6 degrees. So this is how we ensure we do this right. So what I'm going to do at O is I'm going to put a dotted line which represents a horizontal, and then I'm going to connect those two, like that. Remember that angle of depression is measured from the horizontal, so it's this angle here which is 6 degrees. We know that this is 9 degrees because it's the right triangle. So we see we have a Z pattern here, so we know that angle B is 6 degrees. And now once I have this diagram, I can actually work through it and solve. Again, I'm going to say to myself right away, and when I look, is 6 degrees is a very small angle, meaning that the angle up here is going to be very large. Therefore, and let's call this point A, AB is going to be significantly larger than 20. So let's call this length X. So if I'm going to write down SOHCAHTOA, we're using an angle, so sine, cosine, we just check mark those. X relative to 6 degrees is the adjacent, so I'm going to check mark A's. And we're given 20, which is the opposite, so I check mark O's, and I see that I'm going to use the tan ratio. That means that tan of 6 degrees is equal to the opposite, which is 20, over the adjacent, which is X. Now this is typically the algebraic situation where students have some trouble, so let's make sure we understand how we work through this. The first thing I'm going to do is get X out of the denominator, and I do that by multiplying both sides by X. And what results is the canceling of the X's like that. So therefore I get X tan 6 degrees is equal to 20. And now I need to get the X by itself, so what I'm going to do is I'm going to divide by tan of 6 degrees. Now there is a temptation here to type tan 6 degrees into your calculator and get that as a decimal, but it's really nice just to leave it as tan 6 degrees. Remember, this is just a number in disguise, I say sometimes. And it makes it a lot easier to do your calculations if you wait to the last minute and actually type tan 6 degrees into your calculator. So these cancel out, so therefore I get X is equal to 20 divided by tan of 6 degrees. So now I'm going to come over to my calculator. Let's actually change the size here a little bit of this guy. There we go. And let's imagine, I've been using this for a previous question. Let's imagine I just picked this calculator up for the first time. I'm going to take it and take sine of 30, and I'm going to see that that equals 0.5, and that tells me that this calculator is in degrees. So remember, you can take the sine of 30 and see that as 0.5. Or another one that's good to memorize is the tan of 45 degrees, which is 1. If you don't get 1 in this case, your calculator is in radians, meaning you'll have to change the mode. So now let's type this in. So we're going to get 20 divided by, there it is, divided by tan of 6 degrees. And I get X is approximately equal to 190, and it says, I believe, to the nearest meter, so 190 meters. Therefore, the boat is 190 meters out to sea. And we're done. So again, math isn't that hard of this question. The place where students typically make mistakes is when they're trying to set up this angle of depression. So anytime you're using an angle of depression or an angle of elevation, pick the point where that angle is measured from and always draw horizontal. And then just move down if it's an angle of depression or up if it's an angle of elevation, and you'll always get it right. I hope that helped.